Using AI agents to turn insights into actions is redefining software. Agents plan, reason, call tools, and execute. Every action demands faster inference. GPUs are designed for compute-heavy workloads like training AI models. Inference, though, depends on efficient data movement. On GPUs, inference runs one kernel at a time, with intermediate data sent back to memory before the next operation begins. That adds delay, burns power, and at scale, turns latency into the bottleneck. So we built something different. The RDU, or Reconfigurable Dataflow Unit, designed specifically for large-scale AI inference. 3-tier memory keeps large model pools in DDR, moves active weights through HBM, and keeps activations close to compute in local SRAM. A single RDU processes inference through its spatial pipeline, with execution streaming continuously across the processor. When 16 RDUs are connected, that execution extends across the system. Together, they operate as one unified inference engine, built to run large models efficiently at scale. Parallelism happens at multiple levels across the system. Pipeline parallelism keeps different stages of execution moving in sequence. Tensor parallelism splits a single operation across chips at the same time. Expert parallelism distributes sparse model workloads efficiently across the architecture. At full scale, 256 RDUs work together across racks, generating thousands of tokens in parallel. With more chips, the system is more likely to operate in the Goldilocks zone, where throughput and generation speed per user stay in balance. Unlike GPUs, which run inference kernel by kernel with communication overhead between steps, RDUs use spatial execution to keep compute and communication moving together. That reduces bottlenecks, shortens total time, and improves performance across chips. The result is faster inference, dramatically lower energy usage, and higher utilization at scale. That scaling starts with the RDU. 16 RDUs come together in one Sambarak SN50, purpose-built for agentic inference, and scale up to 10 trillion parameters across 256 chips. Sambarak is ready to deploy in existing data centers, delivering high performance per user and high throughput at cloud scale. Built for the agent era,